This video is for Lesson 8-1, Slopes of Parallel and Perpendicular Lines. Learning goals are to make conjectures about the slopes of parallel and perpendicular lines, and to use slope to determine whether lines are parallel or perpendicular. Here we have a picture of a skateboard ramp. It says the new ramp at the local skate park is shown above. In addition to the wooden ramp, an aluminum rail, not shown, is mounted to the edge of the ramp. While the image of the ramp may conjure thoughts of flips and grinds, there are mathematical forces at work here as well. Number one, use the diagram of the ramp to complete the chart below. First, let's describe two parts of the ramp that appear to be parallel. There could be multiple answers to this, but when I look at this ramp, I think that this top segment, segment BE, is parallel to this segment here, segment DF. Now in this drawing on flat paper, they have 1-point perspective, right, with a vanishing point over there to create the illusion of 3 dimensions. But if we think about this in reality, the top edge of the ramp would be parallel to this bottom edge. Likewise, I think that segment BD is parallel to segment EF. Now next one, describe two parts of the ramp that appear to be perpendicular. Well, there's more than one possible answer, but it looks like that segment BC is perpendicular to segment CD right there. It looks like that segment CB would be perpendicular to segment BE, right? The vertical and then the horizontal would be perpendicular. Or segment BD is perpendicular to segment DF, that there would be a 90-degree angle right there. Again, you've got to think of this in three-dimensional space and think about a real ramp of how that edge would be perpendicular to that bottom front edge. Last question, describe two parts of the ramp that appear to be neither parallel nor perpendicular. So lots of possibilities. Segment BA and segment AC, they form at this acute angle. They're not perpendicular nor parallel. Similarly over here, BD and DC, right there. That's not a 90-degree angle, and those aren't parallel either. So there's lots of possible answers on this last one. Now number two, recall that the slope of a line is the ratio of the vertical change to the horizontal change. In algebra class, we often call that the rise to the run. If we use these variables to represent ordered pairs, x1, and this should say y1 here, and x2, y2, to be any 2 points on a line, and we use the letter m to represent the word slope, explain why the slope can be calculated using the equation m equals y2 minus y1 divided by x2 minus x1. I hope that you recognize that equation from algebra as the formula for slope. So this is asking us to explain why this works. Well, by definition, slope is the vertical change to the horizontal change. And finding the difference of the y-coordinates finds the vertical change between 2 points because the y-axis is your up and down axis. If you had a dot here and a dot here and you subtracted their y-coordinates, that would tell you how far apart they are vertically. And the difference of the x-coordinates right here finds the horizontal change. Again, the reason for that is because the x-axis is your horizontal axis. If you had a dot and you subtracted their x-coordinates, that would find you that horizontal change. So here is our explanation of why that formula worked in algebra class. So here we have this complicated drawing with all of these segments just all over this coordinate plane. We have the x-axis across here, the y-axis passing through. Right here is the origin at 0, 0. And we can find ordered pairs for any of the rest of these dots that we need. For example, point A is 12 to the left and then up nothing, so it's negative 12, 0. Point X is negative 12, comma, and then it looks like 5 1/3. So any of these points we can find the ordered pairs. Number 3, The diagram above shows a cross section of the skate ramp and its railing transposed onto a coordinate grid. Calculate the slopes of segment XW and segment XU. So the letter M is the word slope. I'm writing a small XW as a subscript. This means find the slope of segment XW. It's a way to write what you're finding the slope of. To find this slope, let's use our slope formula. It's y2 minus y1 divided by x2 minus x1. So what are the y coordinates of points x and w? What is the vertical change between x and w? Here's point x, and here's point w, and vertically, the amount of change is 2/3 of a unit. So that subtraction turns out to be 2/3. Now, the difference between the x coordinates. This x coordinate is at -12. This x coordinate is at -10. But what's that horizontal change between those two brown dots? It's 2 units. And 2/3 divided by 2 is 1/3. So our slope is 1/3, or a 1:3 ratio. Okay, let's find the slope of segment XU. Here's x, here's u up here. So what's the vertical change from x to u? It's 2/3 and then 2 more units. So it's 2 and 2/3. And then let's find the horizontal change between x crossed to where u is. X is at -12, and the x coordinate of u is at -4, and the change from -12 to -4 is 8 units. So we have 2 and 2/3 divided by 8. This makes 1/3, or a 1:3 slope. Question B, explain why the slopes of segment XW and XU are equivalent to the slope of XT. So here's XT, up there to T. Why is the slope from there to there, the slope from there to there, equivalent to the slope from there all the way up to there? And the answer might be that x, w, u, and t are all on the same line. So any 2 points on the same line will have the same slope. Number 4 is a chance to practice finding some additional slopes. So again, we needed to know the ordered pairs. We need to know the locations of the endpoints. So for A, B, A is at -12, 0, and B was at 0, 4. We're going to use our formula. y2 minus y1, that one's y2, that one's the y coordinate of the first point, divided by x2 minus x1. That number is x2, and that one there is the x coordinate of the first point. So 4 subtract 0 is 4, and 0 subtract -12 is 12, and this reduces to 1/3. Question B, point X is located here, point T is located here. So we're going to take y2 minus y1 divided by x2 minus x1. Again, the pattern is like this. This is x1 and y1, the x and y from the first point. This is x2 and y2, the x and y from the second point. So 9 minus 5 1/3 is 3 and 2/3. And -1 subtract to -12 is 11. Let's do this division and get a final answer. This turns out to be 1/3. Okay, question C. Point W is at -10, 6, and point G is at -9, 3. So 3 minus the 6 divided by -9 minus the -10. 3 subtract 6 is -3, and -9 subtract -10 is 1. And this simplifies to -3. Okay, question D. Here are the 2 ordered pairs. So we're going to go 6 minus 9 divided by 0 minus the negative 1. 6 minus 9 is negative 3. 0 subtract negative 1 is 1. And this simplifies to negative 3. Last one, question E. We want segment AD. So what I did was I went to that picture. I found the ordered pair for point A. I found the ordered pair for point D. It was over here. And I wrote those in purple. We have negative 12 comma 0 and we have 6 comma 0. So our slope is 0 minus 0 divided by 6 minus the negative 12. And this is 0 over 18, which reduces to 0. So with ordered pairs, we were able to calculate the slope of this line as 0. We could have done that visually from the picture, right? If we draw a line from this dot, crossed over to this dot, that is a horizontal line. And horizontal lines have no rise. They have a slope of 0. So our answers fit what we visually could find from that picture. Next, complete the chart by stating whether each pair of segments appears to be parallel, perpendicular, or neither. Then list the slopes. So segment AB and segment XT. Here we have segment AB and segment XT was this brown one. These look parallel. So I've written the word parallel in the chart. Now it asks us for the slopes. We have found the slopes of several of these in the previous question. The slope of AB was 1/3. And the slope of XT, here that was the next question, that was 1/3. Well, that's interesting. Parallel lines and the slopes are the same. Now segment WG and segment TJ, you look at that picture and they are parallel. Now segment WG, we found that slope, negative 3. Segment TJ, here's where we had found that one. It was negative 3. Parallel lines, and they have the same slope. Okay, segment XT and segment WG. XT and WG. XT was this top brown line, and WG is this one. That looks like a 90-degree angle. So in the chart, I have filled in the word perpendicular. Now it asks us for their slopes. So XT was, question B here, the slope was 1/3. And WG, that was question C, and we had found that the slope was negative 3 over 1, or negative 3. What's the connection of these slopes? Well, they're not the same. Is there any relationship? Okay, next question. These two segments turn out to be perpendicular as well. Segment XT had a slope of 1/3, and segment TJ, that was this one here in question D, that was negative 3. Remember, it was negative 3 over 1. We reduced to negative 3. What is the connection of these numbers? Okay, those next two had no particular, they did not look parallel, nor did they look perpendicular. Question 6. Based on the chart, make conjectures about the slopes of each type of segments. Well, the parallel segments look like they have the same slope. Perpendicular segments, our examples were the 1/3 and the negative 3 over 1. If you multiply those together, the product is negative 1. So that's one observation we can make about the slopes. And if we try to give a vocabulary word to those numbers, we could say that they are opposite reciprocals. 1/3 is the opposite reciprocal of negative 3 over 1. Question C, the segments that are neither parallel nor perpendicular, their slopes have no special relationship. Here are some check your understanding questions, so I'll pause the video. Right, in this lesson, we made some conjectures about the slopes of parallel lines and perpendicular lines. We said that the slopes of parallel lines would be the same. And we conjectured that the slope of perpendicular lines would be opposite reciprocals. We're also able to use slope to determine whether lines are parallel or perpendicular. Think about how you would do that. If you knew the slope of two lines and the slopes were the same, you could conclude that they're parallel. And if you knew the slopes of two lines happen to be opposite reciprocals, then you could conclude that the lines are perpendicular.